Hi guys, like to do a little algorithms in between lessons, just a little look forward. We'll touch on these topics in future lessons. So we have pangram conversion. So let's just see. We've seen this sentence before. We'll say the quick brown fox jumps over the lazy dog. This is a pangram. Pangram is at least one set of the alphabet is involved there. So out of order, of course. So let's just go over in steps. An algorithm is just a set of steps that we follow. So let's go over what we need to do to get this to convert over to the alphabet, okay? So we want to create a function that converts pangram into the alphabet. So let's see what's going on here. We got to get, let's convert it to case. Let's normalize a little here and say that the first step is we want to get it all one case. So we want to say that, lowercase, say. Okay. Second step is we've got more than 26 there. It's quick count there. You got at least 40. So you want to do, let's see. We want to throw it. We want to get rid of duplicates. So we want to get rid of duplicates. Third thing we want to do. Let's see here. We want it sorted, right? Because the alphabet is less graphical order, so we want to sort it. The last thing we want to do, we got to bring it back. Well, that's about it. We got to get rid of any things that we don't want. So we'll get rid of. We'll say anything that's not. We want to get rid of the spaces that we add by doing all this stuff. So we'll get rid of. Well, that's basically our algorithm, right? So we'll leave it there. The rest stuff is normalization. So we'll bring it back over here to Python. Alright, so the first thing we want to do is get all our letters to lowercase. So we'll have our, well, we're going to do this all in one step. And it's going to be, then we'll convert it down to a function. Alright, so you shouldn't code this way, but for the sake of this being quick. So we want to say that S is our string, so we want to say the quick brown fox. Jumps over the lazy dog. Okay, and then we want to say, first thing we want to do is go S equals, we'll put it this way, we'll say S dot lower. Second step is to get rid of duplicates. The way we can do that easily in both in all languages is throw it into a set. A set by definition is it has no duplicates, okay? So, without getting into theory there, so has no duplicates. So, our third step is we need to sort it. So we can't sort a set because of the hashable type. A hashable type is not indexed 0 through n there. It's by key value. So it's hashed. So we need to throw it back into a list. So we'll say list. The reason why we don't put dot sort here is because sort, that method returns is a void. It's a void, the method does not return it. So we would annihilate our list if we did that. So we're going to say here sorted. And we put that. And so now we have a list here. We need it back to a string. We need to probably put a join here. So we'll bring it back to here. Our delimiter being nothing and then join an empty string. And we'll join it back together. One more thing here is we got some probably extra spaces at the beginning because of our set and our sorted stuff like that. It's putting it all at the beginning. So space in our ASCII would be, I believe, 32, and our ASCII code value there, and we'll touch on that going forward. If I say this, so I want to get a strip, and that should go ahead and do it. So let's see what we got. We got the alphabet. Good job. So we have here our algorithm that we followed, and that's basically we're taking all lowercase, we get rid of duplicates, and then we sort it. We've got some extra stuff going on with the code in that we're bringing it back from to a list and set and stuff and so forth, but our algorithm remains the same. So let's actually do this out the way we probably should code it, rather than some fustigation right there. It's overly complicated. So we'll say definition pangram, and we'll say convert, and we'll say message, and then we'll convert it over. So what we want to do quickly is we want to say we need to assign it, rather, because we'll lose our list. Remember, strings are something called we'll look at in the future, immutable. Immutable meaning that once we create them, we cannot change them. We can manipulate strings, but we're actually not manipulating the original string. We're actually creating a new one. So be careful there, because you can get into some optimization issues if you got a million iterations through a loop, and you're doing something to a string each time. You're actually creating a million strings for garbage collection to come pick up. So be careful there that you want to use some kind of Java. You have string buffer and string builder. The difference between the two would be thread safety. We're not going to go into that. But you look into those two things, your buffers, string builder in Java and string buffer. They're the same class, but one's thread safe. Okay, so we'll go on here and we say the first thing we want to do is we're going to do message.lower. Okay, then we keep going, and we have to assign it, like I just said, that strings are immutable, so we'll lose it. Meaning that if I were just to say s dot throw it into a set, okay, then I don't keep this. This doesn't convert it to my original string would say the same. So this is equal to that. Is assigning header. Okay, so next step. What's our next step? We need to remember that set is a hashable type. What hashable means is that it's not indexed 0th based. It's indexed, and that it's key value almost, or like a hash table or hash set, and that there's a we won't touch on that. It's a key value pair. So in other words, we can't say set s now 0 to index it. Okay, because it could come back in any order. It might change. It might not. It may. It doesn't. It depends. Okay, so we'll throw it into a list so we can sort it. Okay, so we have our list there, and we're carrying each step out. We could combine some of these. Makes sense. In other words, it makes sense to sort it up above, but we'll do it here. The reason why we don't say s equals s.sort is because sort is a void. And like we said before, we say sorted, and we'll throw s into it. Now we have it sorted. We convert it back to a string. We have our delimiter being an empty string, and join and s. All right, so we can say this here. It's not going to complicate things. So we're going to say strip, and that's basically getting rid of any white space to and from, left and right. So we can actually, in Python, if for a little syntax lesson here, we can say L or R for left and right, but we can also do full strip. So we need to return. Uh-oh, we missed something. Remember, strings are immutable. Oops, sorry. And that the last statement won't matter. Say if we type S. So we actually didn't assign it, so we need to do that again. That's a pointless step in there. Remember, if you don't assign it here, so we say s equals join s. That's true. Okay. And then we're going to return as, we could just turn, we're doing everything carried out here. Return s. Okay. Now we have our pan-grain converter. Let's test it out. Alright, so we're off the screen there. Let's get you back on the screen. We say pan-gram convert. So we'll say pan-gram. Do we have our message there? No, that's from inside of our method. We can't do that. Obviously the scopes that are arranged there. So we have s and the quick brown fox. So let's throw s into our pan-gram. Convert. And we put in s. And we get back the alphabet. Good. We know that our function works. I don't know many other pangrams. You could put this. You could take the alphabet itself, and that you could take the alphabet, and you could just say reverse it or something, and you get that, and then we could throw that into our pangram convert, and we'll say the last value, and we get our alphabet again. So we can tell that it works for our values. So there you go, guys. I wanted to maybe touch on this, in that let's go ahead and get the alphabet. I bet you guys don't think that this is, well, here's the alphabet. Whoops. Let me string. What is it? ASCII. Alright, so that gives us the alphabet. And how we could get that by doing this, we could say, we know that the ASCII value starting with the lowercase a is going to be 97 through 123. The uppercase is going to start with 65. So we could say here, and we'll go into this. Remember, this is a look ahead, so we're not, I don't expect you to understand this, but we're getting into our ASCII table next. And our Unicode. The ASCII is a subset of Unicode, okay? And Unicode is basically all characters. It's over 1 million characters. So we'll throw this in there. We'll say I for I in range, and we'll say 97, and we got 26. So we'll go 123. 123 is not included. We're headed to 122. So we should get our alphabet. Interesting enough. Now, what does that tell you? That, let's see, the ordinal value of A should be 97. Tells you that our char type is numeric. Okay, so how do we do that? Let's say in Java, we'll just do it in Java for the sake of doing it. So, we'll say for I, we gotta put our type there. Python and Java differ in the sense that, remember I said in the beginning in our introductory video that they're different. Is that Python is dynamically typed and Java is statically typed. So the difference being that, well, we'll go over that if it brings us to concepts, but which is a concept, a big concept, but in dynamic binding and how we do that. But we have to explicitly state the type in Java. So we'll stop there. But int I equals 97, and we'll say, well, I is less than 123. We'll say I plus plus, and we shouldn't need. We should include the brackets in case we want to add extra lines later. But if it's only one line, it will read the next line over. The next line underneath there without brackets, but we'll delimit it because we might want to add some later, so it's a good practice. So we'll add here. So we need some casting here. So we'll say the char value. So we'll go ahead and put system.out.println. You'll notice that Java, the verbosity is alone is a lot more than the Python. So we'll cast it. We'll cast. This is how you cast. We have parentheses, and we'll take our I value, and that should go ahead and print our alphabet. We need a semicolon. We also need to delimit it. I don't know that that'll call. There's our alphabet quickly. Let's go ahead and we can print that without the new line there, and you should be able to see it better. And should be all in one row. And we'll go ahead and print that, and we get our alphabet. Interestingly, we did the same thing in short form over here. We can do it in long form if you'd like. So we're saying for I in range 97 to 123, and we'll go ahead and print the char character of I. We're doing our number conversion there, and we get our alphabet. We can do that, same problem as before. We want this and we want this. So we'll go ahead and print that with a comma. That should put it out into one line there. So we get our alphabet. So that's just a look forward into our ASCII. That's where we're going next. So hopefully this is we'll grease the pump there into what we're going to be looking into next. Thanks for watching, guys.